Sorry for the late start. It is well past 10, but we were all in a meeting. So, time for late.NET API review. We have a lot of stuff and not a lot of time, so let's see what we can get through. First up, we're returning to add string key dictionary, read-only span of char lookup support 27229er. Mr. Tobe.
Yeah, so first, just point of order. If for future, we might want to figure out a way to automatically, when things go from API ready to review to API needs work and back to API ready for review, we might not want them to go to the end of the list because it leads to some gap between discussion. But that said, we discussed this previously, and there were a couple things to revisit, so it's coming back. This is all about being able to index into dictionaries and span and hash sets and whatnot via things like read-only span of char. So if you have a dictionary of string comma t value and you want to be able to do a lookup with a read-only span of char, you shouldn't have to allocate a string just to do that. The original version of this it came in basically with extensions on dictionary for all the operations, basically overloads that took a read-only span of char. And what we talked about last time was, well, what would it instead look like? And we should instead pursue an approach where we basically have sort of a view over the dictionary. So just a single extension or a single method for going from a dictionary to the thing that you can then perform the lookups on, and then that thing has all the APIs. In that time, it's also become clear that there's a much higher chance that for .NET 9, we will have support for allow ref struct, basically the ref struct anti-constraint. At which point this no longer needs to be constrained to just be read-only span. We can make it work for any kind of mapped type. So you can construct a dictionary with a T, and you could do a lookup with a U, and as long as the comparer that's used supports that mapping, you could then use this support with it. So this is now written to reflect working with anything rather than just with read-only spans. The basic idea then is you have a dictionary, and the names I've proposed, which we could discuss, is either get mapped lookup or try get mapped lookup, and you're basically giving it the dictionary and the kind of key that you care about, and you get back the view over it that supports indexing with that kind of key. And then what this requires is that the dictionary was constructed with a comparer that implements the interface that allows for that particular mapping. Our built-in string comparers, for example, will support a mapping between read-only span char and string. So if you were to say get map lookup string comma t value comma read-only span char, it would succeed. But if you were to say string comma t value comma foobar, unless you had provided a comparer that implemented the relevant interface for foobar, it would fail. And that's also where the try comes in. Basically, I want to be able to use a span to look up in this dictionary if it will be supported. If it's not supported, then I don't want to incur the cost of an exception. So then those set of operations that get map lookup and try get map lookup would be exposed for dictionary, would be exposed for hash set, would be exposed for a concurrent dictionary, and so on, which also means that each of them then needs that mapped lookup type, which I proposed as having as a nested type within each, allowing them to all be the same name, kind of, and sort of a similar scheme as with an enumerator, but all have the same name, so you can have dictionary.mapped lookup, hash set.mapped lookup, and so on. And then that exposes the actual APIs for use. That's the idea.
Why are these extensions instead of primary methods?
Just to keep them off of the main type. They could be. if we wanted them to be, but we've been very hesitant to put those kinds of APIs onto dictionary or hash set, given that it would mean that every dictionary would then possibly have have the code for that extra method, which then also means it would have the code for the mapped lookup type that it returns. So basically a trimming thing.
Okay. But in the current shape, does it allow for good inference, or do you end up having to specify the generic arguments?
You have to specify the generic arguments.
It's sad.
But we could make them instance. It just means that every dictionary then gets that thing.
Because I think you're missing a T here. Because if that hash set get mapped lookup is an instance method, then yeah, you had to specify T mapped, but as an extension method,
Right. You wouldn't have to specify T.
you'd have to specify both T and T mapped.
Right.
Because to my knowledge, the language still doesn't allow partial specification.
That's right.
Yeah. And is this substantially different from what we talked about previously? Is this just generalizing it to ref struct, or is this a totally different approach? Because it feels similar to what we talked about before.
It's so if you scroll down to option 2 below. So option 2 is basically what we talked about last time, at which point we said, we want to shift to an approach that's like option 1. So we talked through option 1, but we hadn't written it down. So I wrote it down to bring it back.
Okay. And then, yeah, in this plan, how do people make comparators that support mapping?
So scroll to the bottom of this section. Keep going. Below option 2. Yeah, right there. Keep going up a little bit. Regardless of approach, that section right there. So we add this, regardless of whether we do option 1 or option 2. Option 2 is what we talked about last time. Option 1 is what we're talking about here. Either way, you need this interface, and the comparer is dynamically queried for this interface based on the T-mapped and the key in question. So your comparer has to implement this, and this is where the get or try get comes into play, because that operation basically just exists to query the comparer, and then try would return false if it couldn't cast, and the non-try would throw if it couldn't cast.
So comparer as the specified interface type, throw or not, and then now this does all the work.
Right, and equals and get hash code here are what you would expect. They're, it's just trying to compare a T versus a T mapped and getting a hash code for a T mapped. And then the only sort of unique thing is this map, where basically it needs to convert the mapped key to a regular key. So this would be like read-only span of char to string in order to produce the string. And this would be for a case where you're doing something like
add,
exactly, or try add.
Yeah. Right, because anything that needed to bind to an existing key wouldn't call that, but if it needs to add something to the dictionary, it can't add a mapped.
Try get value would never use it, but get or add on a concurrent dictionary, or try add on a dictionary, or add on a hash set if the item wasn't already in the set. Basically, in order to store the value, it needs to be the kind of key that's being stored, and that means mapping the provided key to the kind that's being stored.
Yep. Yeah, so there's a question in chat about the iDictionary and iRead-only dictionary interfaces. I assume that because we need all of the work of these mapped lookup types has to actually happen within the specified type, so there's nothing we can do for
Right. It
interfaces.
has to actually understand the underlying implementation. Um, you know, unless we, if well, yeah, it has to understand the underlying implementation. It has to be able to say, uh, for an arbitrary dictionary type, given a key that the dictionary knows nothing about, hash it according to your scheme and find it in your data structure. And it can't do that unless it knows about the implementation. So I don't think we can do this on top of the existing interfaces.
Mm-hmm.
Which is also why we have something here for each type that's relevant. And in my prototype for this, it's a lot of copy paste tweak for existing APIs. It's basically copy the code and then make it compile.
Yep.
Yep. Yeah, so I like the approach of the mapped lookup type. For one, it means we don't have to do the is test every time you get the mapped lookup. It told you it worked. You call it. You're happy.
Right.
The the only part of this that I don't really like is how ugly the specified generic call is going to be. But
for the inference, you mean?
yeah, the lack of generic inference.
I think. Can you scroll down a little bit? I think to like concurrent dictionary, for example. Yeah. So for concurrent dictionary and frozen dictionary, I made them instance methods because we're less concerned about the size there, just because they're less common.
Mm-hmm.
But I was still very nervous about doing it for dictionary in particular. We could certainly say that we want to overrule that, but I think there was some nervousness there about what that would mean for application size if this was added to every dictionary instantiation.
Right, because we'd get a new copy of the code for every time that a T key or T value was a value type.
Yeah.
Which means copies of dictionary.
No, I don't know exactly how that works when there's an extra generic parameter. I would need Mikhail or Jan or someone to tell me, because it's not just an extra method on a dictionary T key T value. The method itself has the extra generic parameter, and so I don't know how that factors into that. If you're not calling it, I don't know how that impacts things. Tanner, do you know?
I believe the way it ends up working is that at JIT time you're going to have the VM type definition, the actual method table for the type is going to end up having an entry regardless of whether it's called or not, and then you would have an additional entry for every single generic instantiation that actually exists for it. And I believe that in turn impacts how trimming ends up working for the type in some cases. But I think in general, the biggest concern is just generics on generics tend to be bad in the first place because of how generic explosion and how it impacts the method table. And so that's the same reason why like half of Span's methods are extension methods and not instance methods.
Yeah, because for non-AOT, my understanding, and I could be wrong in reinterpreting Tanner's answer, is when the type gets synthesized, what it leaves in the method table for that type for the generic is the meta lookup, and then when you get the specified generics, now it's like, the body's over there. And so every time you hit a new generic, it has to go JIT a new method. Same as every time you instantiate a new generic type, it has to go make a new clone of it. But dictionary is used a lot with value types, and every value type gets a distinct clone, as opposed to all the reference types, which get the same method bodies.
Yeah. I mean, we could say, I'd be happy to follow up after this and basically say, approve it with either, whichever is more appropriate, and then I can go have a conversation with Jan or whoever to basically say how bad would this be.
Right, because this ends up being, you have to do like get mapped lookup of
string, comma,
string,
int, comma, read-only span
yeah.
char. Yeah. And it's that versus get mapped lookup, read-only span char.
And using our don't say var rules.
Right. The left-hand side is going to be the same regardless of whether it's instance or extension. But
It'd be nice if we have the conversation with Jan regardless, and if we write a very small doc to put in like .NET runtime docs, something or other, maybe near the API review process stuff, just to go over like, here's how we want to handle generics and why, and that way we don't have to, every 6 months try and remember what we discussed 6 months prior on what the rules are.
Yeah, I like that.
Yeah, I think that's ugly enough. It would hit my personal var.
I'm sure this stuff will evolve over time. The rules will evolve over time.
Yeah. And none of us can ever remember the exact rules off the top of our heads. So
yeah, we just have a general idea that we want to be concerned.
Yeah, I mean it's not terrible, but it's also not nice. So
I wouldn't be surprised. My expectation is the two most common uses for this will be either your dictionary is stored in a field, and instead of storing the dictionary in a field, you store the mapped lookup in a field. Or most of the time you're just using the dictionary normally, but every once in a while you need to do an operation using something else, and so it becomes dict.get mapped lookup.get try get value or something like that. And then you wouldn't, for that latter case, you wouldn't have the left-hand side of the expression here.
Right, and when you're walking through it, this is certainly a much more pleasant syntax.
Yeah.
And I guess anybody who's using this as a common thing, you could just make an extension method that hides the whole type structure here.
Yeah.
So you would
or even an extension method that combines it with the individual operation you want to perform, like a try get value.
Yeah. All right. Does anybody else have notes other than the extension versus instance methods?
What do people think of my naming choices? Do we like mapped lookup and t mapped? Do we think we need something, and t mapped key? Do we think we need something better? That was sort of natural to me, but I'm totally open to being told it sucks.
The only reason why I don't like map is because we don't really use the terminology map for data structures, but in other languages it often means bidirectional. But
and in other languages, dictionaries are called maps.
Right.
Yeah, that's also
and that's the kind of the only thing that I don't like about that.
Call it alternative.
I think in my initial design for this, I had alternative. I'd be fine with that. Alternate or alternate lookup, alternate key. Equivalent. Alternate's not bad.
Is there something wrong with just calling it get lookup or something?
I still need something for the t mapped key part.
Because we need to name this guy.
Yeah, I have to say I like alternative. Like that's I kind of describe what's happening too.
Okay, so alternative, alternate.
Fair enough. I didn't really. Yeah, alternative. I think is. I think alternate key is probably better.
Get alternate lookup, T alternate key,
Yeah.
and I alternate equality compare, and I guess alternate lookup.
Yeah.
Yeah, I think that sounds good.
And I might have missed this, but like, did we conclude we don't want them extension methods, or did we
I
just
think we
talk
conclude
about it?
we're approving either, and we need to go have a conversation to understand how bad it would be as an instance.
In particular, I think if we've got the alternate lookup struct as a nested type on dictionary, it might just throw out things in general anyways.
Sorry,
because
can you
it's a
elaborate, Tanner?
generic type in a generic because it's a generic type in a generic type, it might already have some of the negative considerations that would be the main argument for not exposing a generic method in a generic type.
I mean, if
Because
that
we
were
only
true, we could
expect
also
it to be
consider
used
moving it
when
out
the
from
keys
not
are
being nested.
strings. Is that the idea?
Oh, sorry, say again, Ima?
Is the idea that we only really need those if the keys are strings, basically?
What are those? What do you mean?
Like, I mean, basically, if we put it on every dictionary, right, it doesn't make sense in all dictionaries. It probably only makes sense if the dictionary keys are strings, so you can map them to a read-only span of char, for example, right?
I think the concern would, yeah, I mean, so that's part of it. It would also be more, even if it was strings, but you never used the functionality.
Gotcha.
Do you still have to pay for it?
And I don't think it just applies to strings. You can imagine it being used for UTF-8 data, which would be at best byte array with a read-only span of byte. You could imagine it being used with ECS with Unity, for example, because you might actually have a dictionary of one type, and you might have another type, and you want to use that as either there might be a conversion or some other thing that you can elide as part of the lookup, where you don't want to do an allocation to do that alternative way of doing the lookup. You could basically avoid an entire cost aspect of conversions or allocations if you have an alternate key that you want to use as looking up the actual key. But what I was getting at is that it might be that because we've got a nested type in a nested dictionary, it being a generic method in a generic type doesn't matter at that point. And using an instance method is fine. And it could be that the discussion is that if we want to save on type explosions and other considerations, that we would also want to move alternate lookup out of dictionary and make it a top level type called something like dictionary alternate lookup or something.
I was hoping to avoid, I hear what you're saying, and I think we should have that conversation as part of understanding what the exact options are here. I was hoping to avoid it being a top level type just to avoid cluttering up the namespace.
And avoid changing everything on dictionary from private to internal.
Yeah, I care less about that, but sure.
Fair enough.
I think it's already all internal anyways because of collections marshal and system runtime interrupt services.
Yeah, or at least a lot of it is.
Yeah.
And does it only apply to built-in types? So if I extend I read only dictionary, I can't use the functionality myself, right?
Right. This needs access. This is using internals of the type, so that's
right.
We have to do this for each type we care about. Someone could do it for their own types.
But it has to be specific for the implementations, right? It doesn't work for every. Yeah.
It's not generic over the interface or anything.
Which is unfortunate, but that's.
don't know how to address that.
Yeah, I don't know. But I
Short
think
of,
that's the only appeal that extension methods have, right? So if you have extension methods that are specific to a type, it's always kind of, that's odd.
right. It's every time we do that, it's for another reason, like
Generic instantiations, yeah.
generic instantiations, or only applies to a specific generic instantiation.
Yeah.
Yeah, like
And there's a few places we've done it for perf too, like with the vector types. It's both to save on generic instantiations and because we want the appears to be an instance method to take the vector by value to avoid it being viewed as address taken and the JIT having to do extra work, which can de-optimize known perf critical code.
okay. So for the this came in after I did the rename. So for the alternate equality comparer, do we like the order of the generic arguments? It feels backwards to me personally, but I don't super care.
I went back and forth on that. No pun intended. I don't have a strong opinion. If you think it makes more sense as T comma T alternate, that's fine.
I think if we did it as T alternate, we would want equals to also take the T first, because then it matches how I-equality compare and other things conceptually do it.
Makes sense.
Yeah. So yeah, I guess.
Although from the concept that this is mapping T alternate to T, and it's functionally then a func of T result, then T alternate is the T, and T is the T result.
Which is actually
and so
why
T does go last in that concept.
That's why I ordered it this way. That was my reasoning as well, although I get that that's a little bit more out there.
Mm-hmm.
But I can see arguments either way, and I'm not sure it's a huge deal.
Yeah. Also, do we have anywhere else that we only name one of the T's?
Yes.
Okay.
But they escape me at the moment.
So we're now using alternate instead of mapped. So convert.
Create, convert. Parse, I don't know.
I like create the most. That also kind of fits in with how we named it for generic math, where we had create checked, create truncating, and create saturating rather than convert, because there may be more work than a simple conversion.
Makes sense.
Okay, so yeah, I think our answer is we prefer them to be instance methods, but we understand dictionary might be special. But Steve, you should talk with Jan, and if he shrugs, then make them instance methods. And if he freaks out about the nested types, then we have to talk about it again.
Are we expecting those to need to be instance methods, or is static more appropriate for them?
Sorry, what are you talking about there?
On the interface for I alternate equality compare, equals and get hash code are uh, uh, they're both in the more in the shape of a static method than an instance method, kind of. So, do we want them instance so that users can capture and use more state, or is static more appropriate for them?
I feel like it makes sense to mirror iEquality compare.
Okay.
I was gonna say I think that it's the same shape as iEquality compare, which is an instance equals of two values and a get hash code that takes in the input.
Do we need to consider? I didn't consider variance at all, but I see we have in on the T for iEquality compare.
It can be in on T alternate.
Oh,
but
we can't do it here because we're returning T from create.
Right. Yeah, you in it and out it, so you can't.
I guess T alternate could be in if we care.
Right. Because it has to map back to the specific T that the dictionary needs.
I don't know that the variance here will ever matter, but I guess it doesn't hurt.
Yeah. And so then this is user extensible if somebody wants to map read-only span of byte to int by comparing their in-memory representation.
They just provide a compare.
They just have to write a compare that does it. So.
Yeah. And then it's really important that the compares iEquality compare implementation and iAlternate equality compare implementation align in terms of what they do.
Right. If yes, the equals of the primary comparison of creative alternate better equal the agree of everything better work out. Don't lie or the dictionary will do nonsense.
But given that, is there any benefit to having this interface inherit iEquality compare of T?
We could, because we would. I right now can't think of anywhere that we would ever accept one of these that's not just type testing on iEquality comparer, which means they should always be an iEquality comparer.
Right.
Does that potentially so the language is tricky sometimes with generics and overloads. Does inheriting from iEquality compare hit that weird edge case where if the user were to specify T alternate as the same thing as T, the language just goes, now I don't know what to call and everything's broken?
No, because T alternate wouldn't play any part in the base type resolution.
Yes, but you have a method where bool equals is provided for both T alternate, T other, and for T left, T right, where if T alternate was the same in both, then in other unconstrained generic contexts, the compiler sometimes goes, I can't determine which one this should be. It's like the same reason why we can't expose a static multiplication operator that takes T vector and T scalar in a generic context, because the language just goes, oh, I don't know what you mean here. These two things could conflict with each other.
I mean, that will always be true here. Like, so anything that is going to be an alternate equality compare is going to be an equality compare. It just means that they'll have to implement alternate equality compare explicitly.
I guess the concern, though, to Tanner's point would be if I just say I alternate equality compare int comma int, and then some local, and then I say local dot equals.
Oh, yeah. Okay.
It doesn't know which one to call.
Right. All right. So I guess we
Yeah,
can't
and while
inherit.
that's not yeah, and while that one's not necessarily super real world because we can just tell users don't do that. The place it breaks down is if you're in another generic context where you have a T alternate and a T, and then you take in an I alternate equality compare T alternate T. I believe the compiler will say, I don't know which equals to call because these two could be the same type.
So forget my idea. Who
Yep.
does this?
Yeah. It might be worth just like testing it out and seeing if we do see a break here, because there's some places the compiler does it right and some places it doesn't. And this is those other cases where I just can't remember which ones it actually hits or not off the top of my head.
Okay. So, the total set of types that we're talking about. We have dictionary, hash set, uh, oh, this is collections Marshall. Different namespace. Oh, I get it. Okay. Concurrent dictionary, frozen dictionary, frozen set. Do we not have a concurrent set?
We don't have a concurrent set.
Okay. We have concurrent bag, though, right?
We do.
Is that
But
two different?
it doesn't have any kind of lookup notion.
Okay. And so we replaced the word map. Are we okay with the word lookup? I know we have an iLookup and it does things, but I'm personally okay with it as a modifier, just making sure that we've talked about it. I don't have another word for it, so.
So I have a question. Sorry, I came in late in the meeting, but does the proposal include any implementers of the new interface, like string compare?
So all of our built-in ones will, but I don't think any of them are public types.
Or is that added to the proposal, or
It
is
just
it?
says here implemented by all string-related comparers.
Oh, okay.
It doesn't need to be part of it.
Go ahead,
I wasn't expecting to make it part of the public surface area, but we could. I mean,
So I have a question on that. I'm guessing that would only be for read-only span of char. Would it be within scope to also do read-only span of byte, or do we not expect string compare to handle UTF-8?
We could.
That would be useful from the perspective of system.json because UTF-8 based lookup is, fairly common.
It really hides the UTF-8 nature of what we mean by bytes.
Yeah, I don't think we'd want it on the string comparer.ordinal, but if we made I wouldn't be opposed to a string or a public type somewhere or public accessor somewhere to get a string comparison with UTF-8 alternate lookup, just so somewhere you had to write UTF-8. This goes back to I really, 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 really wanted us to just make a char 8 that lowered to byte but did not equate byte in API. Yeah, so I don't think this is a public type.
Well, the
Yeah.
the concrete types that we would actually implement this on are not public.
Right. So it's ordinal doesn't return an ordinal string comparer. It just returns
Right.
string comparer, and you don't get to know what the actual type is.
Exactly. And similarly for equality compare dot default, we would make equality compare of string dot default, implement this as well.
Right.
And that's also not a public type.
Yeah. Because I had started from your comment and Eric's question. I had already started like, oh, I should go write down all the type. Wait a minute, they're not public. So.
Yeah. And we can't just add it to, even if we wanted to, we couldn't just add it to the base string compare.
Right. Because we don't know what the equals implementation is of a custom comparer. And we don't want the default to be call create and then call equals.
Right.
So yeah, modulo the syntax errors in here of places that there aren't enough generic specified, like this one.
Yeah.
Seems
I have a
right to me.
prototype of all of this, so I'll just change all the names to map to what we talked about, have a conversation with Jan about whether instance or static. And then I just need to wait for a compiler that actually supports allow ref struct.
Yep. All right. That leaves us with 8 minutes in the meeting.
I think we could probably do the next tab in 8 minutes. But if there's something else that someone thinks we could do faster.
Which one's the next tab?
This one.
Making process asynchronous tasks as they complete easy by using iasync enumerable 619 or 59er.
So today we have tasks.whenAll, which returns a new task that waits for all the supplied tasks to complete. We have task.whenAny, which gives you back the first task that completes. Not infrequently, people want to to give a set of tasks, and given a set of tasks, you want to process all of them, but you don't want to wait for all of them before you start processing any of them. You want to just sort of process them each as they're available to process. So I'd written a blog post like 12 or 13 years ago that is people just kind of copy and paste. Since the introduction of channels, people do something similar with channels where they create like a channel.create unbounded, and then they hook up a continuation to each task that adds itself to the channel, and they read from the channel. Logically, that's what this is doing, although it's more efficient. Basically, you give it the tasks you want, and it gives you back an iasync enumerable that yields each task as it completes. And so you can just say await for each, var t in when each, and your tasks, and then each task as it completes is yielded out of the async enumerable. And assuming we're okay with the premise, this basically has 3 overload for each generic and non-generic. There's an overload that takes an array, there's an overload that takes a span, and there's an overload that takes an IEnumerable.
So why do we need an overload both for span and for array?
2 reasons. If for a language that doesn't support span, the task, well, for one reason really, 2 reasons. I'm alternating. We basically say that we have said that for main APIs, anywhere we take a span, we should also consider taking an array. I'd be fine if we just start dispelling with that reason. There's another reason that's more subtle today, which is if you did have an array and you tried to pass that to span to an overload that just takes a span and an overload that takes an enumerable, it will fail today with an ambiguity error because it doesn't know whether to use the implicit conversion from array to span or the implicit conversion from array to enumerable. And so it will be ambiguous, and the array overload explicitly disambiguates that. If that problem were solved, and if we didn't care about having an array overload when we have a span overload, and we don't care about, well, yeah, that's basically it. Then we can get rid of the task array.
The other reason would be if we cared about VB being able to use params, because they won't get param span.
I mean, presumably that's the same as why we expose arrays when we expose spans.
But with params, it's the extra special of the params keyword is only useful on arrays for VB.
That said, I don't remember what kind of support VB has for async enumerable to begin with.
Yeah. And there's no ambiguity in these methods. Like things faulting will behave in a sane way, and it knows when it's succeeded because it has returned
like
everything.
It's like when any, in that you get back the task that completed. So it's up to you then to look at the task and say, were you successful or failing or canceling? You're just getting back the task object.
So in background and motivation, if finished task returns a faulted task, then process of await finished task is where the exception throws.
Yeah.
So. And
interestingly, I have seen folks write code like the first example in background motivation there, and that is order n squared, even though it's kind of can't really tell.
Mm-hmm.
So for a lot of tasks, that's very much not ideal.
I don't really have any proposals here, but I would like to see a name that I guess stresses the fact that the order of tasks isn't preserved. If that would ever be an issue for people consuming this.
Mm-hmm.
I'm guessing people know.
Do you think there's an implication that this will yield them not only when they're completed, but also in like order of being specified?
Sorry, I didn't get the question.
Like, you're concerned that if someone writes when each T1, T2, T3, T4, that they would be surprised if T3 emerged before T2.
Yeah, assuming that they just find it in IntelliSense and don't read the documentation, they might assume that it's monotonic and, get bugs because of that. Or, I don't know.
I would believe that if it was for each. But
I guess I'm just I think
no,
the
I
name
hear
is okay.
what you're saying, Eric.
Yeah.
I don't have a better idea though.
Yeah. And I may be colored by already knowing what when any does, but I think that we already have the notion of the task when means order is not guaranteed. Personally. And since I apparently killed that conversation, Steve, your params when possible means lower. You want this exposed on lower TFMs, or just you might check it in before the param span lands?
Oh, I wrote this before param span landed, and it already has, so you can just remove that when possible.
Okay.
Well, it's already been checked into the compiler. We don't yet have it in .NET runtime. We're waiting for the PR that has been out for a month to be mergeable.
Yep.
It keeps running into different issues.
Do we have anything weird on task? Like for each?
There's a lot of weird things on task.
I'll eventually find it. Okay, so we don't have a for each, which I guess makes sense because that's not really task's job. That's the list you have it on. Yeah, so I guess really it's the any is what says I don't know which one it is, but I'll tell you. So win any, I'll give you the value back, and I feel like wait any gives you the index.
Wait any gives you the index.
Yeah. So yeah, if it was task for each, yeah, again that wouldn't make any sense because it's inherently the lists problem. I'm just trying to think of why I don't share Eric's concern that this implies, or might to some people imply, an ordering.
I'm just approaching it from the angle that people would just read that as a weird when ending or something.
Yeah.
But I think the documentation would dissolve any doubts as to what this is doing.
I mean, we can make it very clear it's unordered results.
Yeah.
Ordered effectively by completion time rather
Completion
than
order.
Yeah.
Yeah. I mean, the other thing would be task dot as completed of things, but I think win each looks much closer to win any than introducing a new as completed concept.
Before you click all good, if the ambiguity between span and enumerable were resolved by the language, how strongly do we care about the array-based overload?
Emo.
Yeah. I don't know what the language would look like though. Like what would that mean if they remove that limitation?
Presumably they would just say the span conversion wins over the enumerable conversion.
Yeah, exactly. Which is what is likely to happen when this is resolved. Fred has a proposal out that makes span a first-class citizen in the language, and that includes overload resolution.
It'd be the same thing as when you have a function that takes an int and one takes a short and one takes a long, and you pass the literal one. Like there's an order that wins.
So the reason why I'm hesitant, so I'm sure that C# will do the thing that will work in C#, right? The problem is what will happen in other languages, right?
Yeah, F#,
And I guess
VB.
that's kind of the where
No,
I'm
the thing
not
is,
sure what that would look like.
To my knowledge, F# never added support for async enumerable, and that's primarily because it has a different conception of async in the first place. So it might have changed recently, but async enumerable wasn't supported back in the day. So you can't actually do a wait for each in F#.
Given everywhere async enumerable has propagated, I would hope there is now a solution for it in F#. Or that one is coming very soon.
And for what it's worth, if there's one forcing function that would create that would make F# to adopt params of span support, that would be exposing APIs that don't have the workaround. As usually happens with new features.
But see, that's because the language doesn't have support, and it doesn't mean that people don't use the APIs, right? I mean, C# doesn't. I mean, C# didn't really have support for observable either, right? It's just you code against it, right?
That's true, yeah. It is a minor inconvenience, I get that, but I would assume that F# would eventually catch up to adding params of span support because it is a useful feature.
Yeah, don't get me wrong. I don't care too much about this particular instance here. I'm just saying, like, when we talk about like language interop, and we talk about in the context of C# is making things better, then I don't know how, as a framework author, we can reason about that in the context of other languages. That's kind of general the problem why I'm squinting.
I mean, I'll tell you that what usually happens is that, C# evolves and the other languages catch up. So they bake in support that is
Well,
able to consume the new shiny things.
so that's true with C#. That's with F#. I mean, VB basically does nothing until until there's like something has to happen or stuff doesn't compile anymore at all, right? And that's relatively rare. So like in general, I would assume like any sort of tweaks we do to overload resolution probably won't propagate to VB. And then the question is that what does it mean if we do certain things, right? But I mean, in general, you could argue like, we can always not have those overloads, and then if stuff doesn't work, we can always add them later, right? Like in that sense, we're not cornered. It's more for things when we design stuff that is hard to change later, but that's a problem.
Yep. I mean, when we started Span, and it's been several years now, so we're all super comfortable with it. I have no idea what the man on the street actually feels about it, but we said high level sort of CS1 types needed to stay friendly to existing paradigms. And I think task, good job Steve, is a high level primary .NET concept, which means we would keep the array overloads. At some point we may decide that's outdated guidance and we stop doing the multiple overloads, but that is what we have written down right now.
I mean, one thing that was nice about C#, but we've generally, I think, lost that battle already, is like, if I remember when I started learning C++ and you call, an innocent built-in framework method and you see what code completion shows you, it's like an unintelligible mess of angle brackets, right, thanks to the STL. And so I feel like that's still a problem for mainline scenarios. But if you look at the resulting code, frankly, if you look at minimal APIs, for example, and you see how people start, where you have anonymous lambdas and you have now collection expressions, I don't think it matters, frankly, because you don't construct the span by yourself. You just say bracket A, comma B, comma C, closing bracket, and then whether that converts to an array or a read-only span, who cares, right? That's probably the only way you can make sense of most overloads anyway. Like, I mean, if you look at console write line, like the average starting dev will have no idea what overload is going to be picked, right? So, but it's probably based on the naming of the APIs, and yeah, I think the intuition would just not carry that forward. So in that sense, I think maybe it doesn't matter. Like my primary concern is less about that and more about, does code actually compile, right? That was the problem with VB, where you have an array, you call a method, it only has a span. Does it even do the conversion, right? And I think that one we have, I think, answered it does, but then it gets tricky with certain constructs where it may not work the way you want.
And Eric, for F#, that somebody has to make a gesture to convert an array into a span, right? They have to call the as span directly.
Yeah, so implicit conversions aren't a thing in the language, so you would need to make those things manually, with not very pretty looking code.
However, F# does have a RFC, which I believe is championed by Don and Vlad, on allowing some limited implicit conversions where there is no ambiguity specifically for types like span.
Yep.
Just because of how proliferating it is nowadays, and they want to make that experience better for users. It still won't be like C#'s implicit conversions, though. There's a lot of rules to make it still feel F# and complain if there is actual ambiguities and stuff like that.
But yeah, assuming async enumerable works in VB, I think we would, in this specific instance, no matter what, want to keep the params array when, so that VB can maintain the benefit of the paramsness. If async enumerable for some reason doesn't work in VB, then I mean, I guess they wouldn't have the keyword support for it, but they should still be able to call the members themselves in the for each expansion. But, so, I guess my vote's erring on the side of being nice.
I'd say the same, especially if it's a lot like most of our array versus span overloads, where the array one just is a one-liner deferring to the span.
Two-liner, check for
Yeah,
null.
that's basically what it would be. All right, so not quite by 3, or not quite by noon, but close.
As close as any 5-minute issue ever gets. So. Alrighty. I think we're still Tuesdays only. Yep. So. And we've hit the last one of the month. So yeah, thanks. Wow, we actually had a really big turnout today. So thanks everybody who joined us. Sorry we had a meeting this morning and started late. We will see you as on time as we normally are on April 2nd. So we get to avoid the whole April Fool's Day shenanigans, at least on this meeting. So, Auf Wiedersehen.
Bye bye.